not everything, not every square root of a quadratic has such a simple form. You will often encounter things like that are not just the square root of something simple, like one of these forms. Like there might be a middle term in there. And I don't actually have time to show you an example of how this comes out in a sort of practical example, but it does happen quite frequently. And so I want to show you how to deal with things like the following example. Let's try to integrate dx over x squared plus 4x, the square root of x squared plus 4x. So there's a square root of something, some squared, some quadratic. It's very much like this business, but it isn't of any of these forms. And so what I want to do is show you how to rewrite it in one of those forms using substitution. Again, all this is about substitution. So the game is to rewrite a quadratic as something like x plus something or other plus some other constant. So try to write it in the form a square plus or minus another constant. And then we'll go on from there. So let's do that in this case, x to the squared, x squared plus 4x. Well, if you square this form out, then the middle term is going to be 2ax. And so that, since I have a middle term here, I pretty much know what a has to be. The only choice, in order to get something like x squared plus 4x out of this, is to take a to be 2, because then this is what you get. This isn't quite right yet, but let's compute what I have here. X squared plus 4x, so far so good, plus 4, and I don't have a plus 4 here, so I have to fix that by subtracting a 4. So that's what I mean. I've completed the square. The word for this process of eliminating the middle term by using the square of an expression like that. That's called completing the square. And we can use that process to compute this integral. So let's do that. So I can rewrite this integral, rewrite this denominator like this, but I think and then I'm going to try to use one of these forms over here. So in order to get a single variable there instead of something complicated like x plus 2, I'm inclined to come up with another variable name and write x plus 2 as that other variable name. So here's another little direct substitution. U is x plus 2. Figure out what du is. That's pretty easy. And then rewrite the integral in those terms. So dx is du. And then in the denominator, I have the square root of that. Oh, yeah. So I think as part of this, I'll write out what x squared plus 4x is. The point is, it's equal to u squared minus 4. X squared plus 4x is u squared minus 4. There's the data, a data box containing the substitution data.